Chapter 2 review for your midterm exam. This chapter covered Newton's first law of motion. So number 10, what were Galileo's experiments? First was the Leaning Tower of Pisa, and it showed that Aristotle was incorrect. Galileo dropped objects of different weights from the top of the Leaning Tower of Pisa, and he observed that objects fell at the same rate and hit the ground at the same time. And this is true when air resistance is small. We also watched a number of videos where there was no air and saw that this was the case. His other experiment was the inclined plane, and Galileo believed that with no interference, a moving object would continue moving forever. Galileo showed that the inclined plane, using the inclined plane, that the ball would go down and then up the other side, reaching almost the same height, and believed the reason it didn't reach the same height was because of friction. And throughout all of this, he developed the concept of inertia. So number 9, what is inertia? Inertia is the tendency to resist changes in motion. It's related to mass, but it is not the same thing. It is not a measurable quantity. So when we ranked items from smallest to greatest inertia, considering your textbook, the classroom table, a car, and a pencil, the smallest inertia would be a pencil, then your textbook, then a classroom table, and then a car. Number 8, how do you apply Newton's first law of motion to a common scenario? So when you are riding in a car that comes to a sudden stop, first answer, what does the seatbelt do for you? It prevents you from flying too far forward. What happens if you are not wearing a seatbelt? Answer is you will fly forward in the car, perhaps hitting the steering wheel, the dash, window, or even flying out of the car. What happens to the open cup of water that you're holding? And be specific. So answer, it will spill forward because it's moving in the same direction that the car was moving before it stopped. So just saying that it spills is not adequate. Spilling forward because you need to take into account the motion of the liquid. Number 7, determine the net force on an object from a free body diagram. So for the first one, we have a 60 Newton force to the left and a 60 Newton force to the right. So the net force is 0. So this one is balanced. On the second one, we have 25 to the right, 35 going towards the left, which means overall it's 10 Newtons to the left. And on the last one, we have 10 Newtons up and 40 Newtons down, which overall is a net of 30 Newtons down. Number 6, apply the equilibrium rule to a scenario to find the unknown force. So in this case, we have 200 Newtons down and 1,000 Newtons down. We add those together, we get a total of 1,200 Newtons. So to have it so that we have it divided equally between two forces going upwards, they're both going to be 600 Newtons. The other example here, we have 12 tons down and 20 tons down, which gives a total of 32. We know that there's 13 over here on the right, and so the 32 going down must be balanced by the 13 in the unknown, which means that the unknown one is 32 minus 13, which gives us 19. Number 5, understand the concept of balanced and unbalanced forces. So are the following balanced or unbalanced? First, a lamp sitting on a table. It's balanced. A gymnast doing a backflip. It is unbalanced. And the last one, the Earth orbiting the sun. Unbalanced. Depending on the definition you're using, you might Google this on the internet and find something different, but we are considering it has to be balanced. Unless it's moving in a straight line at a constant speed, and orbiting is not in a straight line, it is in a circle. Number 4, understand the common misconceptions regarding force and motion. First, what force is needed to keep an object in motion at a constant speed of 10 meters per second to the right? The answer is there's no force needed to do that. Next, a ball is thrown up into the air. How long does the force applied by your hand affect the ball? The answer is only while your hand is touching the ball. Next question. A ball is thrown up into the air. After the ball moves upward towards its peak, it starts to slow down. Why does it happen? The answer is because the force of gravity will start is pulling it down. Number 3, Sir Isaac Newton was a very influential scientist, and many consider him to be the most influential scientist ever. Why? So you should know some facts about his life and why he is so important, and you should take a look at your notes for this, but it is not only his 3 laws of motion, that's what we're focusing on, but you should know a couple of other things that he did because he did a lot. Number 2, what are the 2 types of equilibrium and how are they different? So equilibrium refers to an object that has balanced forces acting on it. So static equilibrium is an object at rest. Dynamic equilibrium is an object in motion at constant velocity. And the last one, what is Newton's law of motion? What is its common name? So an object at rest stays at rest, and an object in motion stays in motion at constant velocity unless acted upon by an unbalanced force. Note, when we first memorized this in class, we did not know the true definition of velocity. So we memorized using at a constant speed in a straight line. But now that you know what constant velocity is, and you should, you can use that instead if you'd prefer. And its common name is the law of inertia. So those are the top things that you should know about Chapter 2.